Catholic University Nursery Career Valencia Aro Kerli 4CMenB vaccine for group B Neisseria meningitidis. Definition: Neisseria meningitidis or meningococcus is a gram-negative, oxidase-positive, aerobic bacterium which microscopically appears as Diplococcus. Is a serious bacterial infection of the membranes that surround the brain and spinal cord.
The prevention of meningococcal disease remains a global challenge as outbreaks and endemic disease continue to make this infectious disease an important cause of death and disability. The highest rates of meningococcal infection and fatality occur in infants and toddlers. Rates then drop, but increase again during adolescence and early adulthood. There are 3 types of bacteria responsible for bacterial meningitis. Fortunately, new conjugate vaccines, when widely used, have greatly reduced several causes of invasive bacterial meningitis and septicemia. However, current vaccines against meningococcal disease caused by Neisseria meningitidis have been only partially effective due to challenges in vaccine design and this bacterium's highly variable surface antigens. Meningococcal bacteria are classified into 13 serogroups based on chemical differences in their surrounding polysaccharide capsule. Almost all meningococcal disease is caused by 5 serogroups, A, B, C, W135, and Y. The diversity of these multiple serogroups creates an unmet need for broad protection from this disease. The structural variability of the bacterium's antigens also contributes to the diverse and unpredictable epidemiology of global meningococcal disease. Serogroup emergence and distribution varies worldwide, not only by region, but also over time. For example, over the past 10 years, the distribution of serogroups in the United States has changed. Previously, serogroups B, C, and Y accounted for 43, 40, and 9% of the nation's meningococcal cases. As of 2006, serogroups B, C, and Y are respectively responsible for 28, 27, and 39% of all cases of meningococcal disease. A similar pattern was observed in Colombia, where B, C, and Y account now for 56, 13, and 29% of the nation's cases. These changes affect not only the epidemiology of the disease, but also the selection of vaccination strategies. As our understanding of the dynamic nature of the meningococcal bacteria's surface structures improves, so too do our strategies for vaccine development. We hope these advances will contribute to the realization of broad prevention of meningococcal disease.
Application in nursing. Serogroup-specific vaccines are used for prevention, routine immunization, and response to outbreak, with the LiProtect vaccine against serogroup B. Protein-based vaccines such as 4CMenB. This vaccine comes from a selection of highly specific antigens identified through completely genome sequence analysis.
Meningococcal disease is a worry for all parents and for all doctors looking after children. However, many doctors don't have a very clear idea of just how big the risk is of getting meningococcal disease. And in this talk I was starting by explaining just what the probabilities are. Some people think that getting meningococcal disease is so unlikely that it's the same as winning the lottery. On the other hand, some people think that it's really quite common and quite easily occurs. The reality is that the chances in a whole lifetime of getting meningococcal disease are around about 1 in 1,000. That's not incredibly common, but it's also not incredibly rare either. And so for that reason, paediatricians may want to counsel parents on whether or not it's important to have their children immunized. The other main point of my talk is that the way that meningococcal vaccines work is by interrupting transmission of meningococcus. It's not so much that you immunize a child and stop that child from getting sick. It's more that you immunize a population and stop the organisms that cause meningitis from being passed around. For that reason, you need to identify the people within the population that are most likely to cause transmission. And in the case of meningococcus, that is actually teenagers. The rates of carriage in teenagers are much higher than in younger children, even though the rates of disease are much higher in younger children than in teenagers. For that reason, the strategies taken towards immunizing against meningococcus, increasingly in Europe, are directed towards teenagers and to prevention of carriage. And we are likely to see more and more countries adopting adolescent booster doses of vaccines to get this effect to occur.
Pros. This vaccine has the potential to confer protection against non-B, meningococcus and other Neisseria species, such as gonococcus. The best way to avoid their adverse sequelae is to prevent infection that could be done by immunization. Cons. The introduction of the serogroup 6 meningococcal vaccine into routine immunization has resulted in a significant decrease in the proportion of the disease in the region. However, this has a minimal or no effect on other serogroups.
Neisseria meningitidis, often called meningococcus, is a gram-negative diplococci that can cause meningitis and life-threatening sepsis. Neisseria are fastidious organisms that require nutrient supplementation to grow in laboratory cultures. Specifically, they grow on chocolate agar and can be isolated on Thayer Martin agar, sometimes called VPN agar, Thayer Martin agar, polymyxin and nystatin, along with other nutrients that facilitate the growth of Neisseria species, while inhibiting the growth of other organisms. Characteristically, Neisseria are oxidase positive and Neisseria meningitidis can be distinguished from Neisseria gonorrhoeae because Neisseria meningitidis ferments both glucose and maltose, while Neisseria gonorrhoeae only ferments glucose. This organism exists as normal flora in the nasopharynx of 5 to 15% of adults and is spread through the exchange of saliva or other respiratory secretions. Virulence mechanism include lipo-oligosaccharide LOS on the outer membrane of Neisseria meningitidis, which acts as an endotoxin and can cause shock and destruction of RBC. Other virulence mechanisms include a polysaccharide capsule that is anti-phagocytic and aids in the evasion of the host immune response. Symptoms can rapidly progress from fatigue to meningitis with fever, headache, neck stiffness. If toxic levels of the endotoxin reach the bloodstream, meningococcal sepsis can develop, causing blood vessels to rupture and vital organisms to rapidly shut down. Complications include Waterhouse-Friderichsen syndrome with adrenal insufficiency, organ failure, low blood pressure, disseminated intravascular coagulation with widespread petechial rash, and death. Treatment includes ceftriaxone and rifampin prophylaxis.
Subscribe.
Issues apply in Ecuador. Signed 2010 and the implementation of a meningococcal conjugate vaccine, a thorough mass preventive immunization campaigns in the meningitis. But the proportion of serogroup has decreased dramatically. The high health rate of the disease are recorded in the broad belt of the African meningitis.
The meningococcal infection is one of the most important infection now all over in the world because the 5 principal serotype involved in this very acute and very, very serious disease are the principal possibility of very, very acute sepsis or meningitis. The 5 serotypes are A, B, C, W135 and Y. These 5 serogroups are very, very important in prevention of this disease and specific vaccines are produced until 40 years, but not important and very, very efficient vaccine, only produced until 20 years with a new technique of production of this specific vaccine against the serogroup C. Is the first vaccine for against this serotype specific. Is produced with a technique particular of conjugation with specific protein of capsule of specific bacteria. In recent year, in 2014, we have a new vaccine against the serotype B. The serotype B is the more difficult for production of a new vaccine because it is a serotype completely different from other, from A, from C, from W and Y. Now we have a new vaccine against serogroup B, very immunologically active and very safety, with high level of safety. And we start in this year also in Italy and in 12 countries of the world. We start very important vaccination campaign for immunization of now at the moment more than 100,000 subjects already vaccinated from 2 months of life and without limit of age of vaccination for this subject with very high results in terms of immunization and we hope also in terms of protection and efficacy.
Conclusion. Neisseria meningitidis is the best common cause of bacterial meningitis. In children and young adults worldwide, the transmission of Neisseria meningitidis is done by contact from person to person or by inhalation of respiratory drugs containing meningococci.
Meningococci are commonly carried asymptomatically in the nasopharynx. Virulent, invasive forms of the bacteria may overcome host defenses and adhere to epithelial cells. Mucosal invasion and transcytosis allows entry of the bacteria into the bloodstream. Here, the bacteria may cause life-threatening septicemia as they multiply to high density and shed outer membrane in the form of vesicles or blebs, causing the host to release inflammatory mediators and cytokines. From the bloodstream, the bacteria can also cross the blood-brain barrier to cause meningitis.